Hello, welcome to the course Coordinate Transformations for Interplanetary, Planetary, Earth and Spacecraft-Based Systems Rotations and Translations Corrections by Dr. Ayonshola Ogundele. In this presentation, I'll be going over course description. Satellite coordinate transformation. The process of converting coordinates from one reference system to another involves calculations such as translations, rotations, and scaling in order to account for differences in origins, orientations, and earth shape, making raw satellite data compatible with local maps and project requirements. For accurate tracking of satellites, coordinate transformation is very critical. This is because of the movement of satellites in orbit as Earth rotates, and as a result, a single static coordinate system is insufficient to describe satellites' movement. Depending on their purposes, satellites use different coordinate systems. Coordinate transformations convert satellite data between different reference systems, ensuring consistent and precise positioning. Satellite coordinate transformation bridges the gap between satellite-derived data and the various local reference systems, ensuring that the data is correctly georeferenced and usable for analysis and mapping. As humanity ventures further into space, achieving the future goals of in-situ resource utilization, in-orbit servicing, deep space station, asteroid mining, planetary protection, and potential for discovering extraterrestrial life is a function of using correct coordinate systems and coordinate transformation. Coordinate transformation, the process of applying mathematical functions to convert coordinates from one coordinate system to another coordinate system, helps to simplify complex problems, align data sets, and enable meaningful analysis by using the most appropriate coordinate system for a specific space mission analysis task. Course modules. This course is divided into 8 modules: Module 1, Module 2, Module 3, Module 4, Module 5, Module 6, Module 7, Module 8. Each of the modules is explained as follows. Module 1, Coordinate Systems and Transformations. Module 2, Earth Center Inertial Frame to Earth Center Earth Fixed Frame, and vice versa. Module 3, Position and velocity vectors to classical orbital elements, and vice versa. Module 4, Transformation between topocentric coordinate system and ACI coordinate frame. Module 5, Transformations between ECAF and ENU coordinates. Module 6, Row PCO transformation. Module 7, Example questions. And Module 8, Exercises. Module 1 is about coordinate systems and transformations. This module describes coordinate transformations and its applications. Module 2, Earth Center Inertial Frame to Earth Center Earth Fixed Frame, and vice versa. The transformation of Earth-centered inertial frame to Earth-centered Earth Fixed Frame, and vice versa is treated in this module. Module 3. This module describes transformation from position and velocity vectors to classical orbital elements, and vice versa. Module 4. In this module, satellite ground tracking station, orbit determination using ground station observation, Case 1 topocentric coordinate system to ECI coordinate frame using symmetrical Earth model. Case 2 topocentric coordinate system to ECI coordinate frame using non-symmetrical Earth model are treated. Module 5. ECAF versus ENU coordinates and transformations between ECAF and ENU coordinates, and vice versa are described. Module 6. This module describes row PCO rotations of aircraft and spacecraft, transformation of row PCO, and applications of row PCO transformation. Learning objectives are as follows. Understanding of transformation from Earth Center Inertial Frame to Earth Center Earth Fixed Frame, and vice versa. Ability to be able to transform from position and velocity vectors to classical orbital elements and vice versa. Understanding of satellite ground tracking station and transformation from topocentric coordinate system to ECR coordinate system and vice versa. Others are understanding of Earth center Earth fixed frame versus east-north-up coordinates and their transformations. To be able to describe rotational rotations of aircraft and spacecraft and their transformations. The course navigation. This course can be taken by going into our website www.a4saerospace.com, then navigate to course categories. Under course category, we have orbital mechanics, analysis and visualizations, which goes to orbital mechanics, analysis and visualization courses. So clicking on this takes to the page where we have the coordinate transformations for interplanetary Earth and spacecraft course, which when clicked will takes to the page where the course can be offered. The link to our course is given in this slide. Thank you for your attention.